100 some
So,
500 by 10.8
related to Jefferson distribute
2 million 100
Jefferson
500.
Good morning, Sir Banal. Good morning, classmate. We are here to report Jefferson's method. Thomas Jefferson proposed the Jefferson's method of apportionment and was the third U.S. president and author of the first apportionment plan used in the United States. One of the most influential statesmen in the formation of government, and also acknowledged as the primary author of the Declaration of Independence. After Washington vetoed Hamilton's method, Thomas Jefferson proposed a new method called Jefferson's method. It was used in Congress from 1791 through 1842. The method tends to favor large states. Jefferson happened to live in Virginia, the largest state at the time. Jefferson's method differs from Hamilton's method on how to solve the situation when the lower quota or initial quota is less than the actual seats available. Steps of Jefferson's method works. First step, initial distribution. First, the total number of sets is determined and initial distribution of sets is made based on population. This is typically done by dividing the total population of each region or state by a divisor, which determines how many sets each region should have. Number 2. Iterative adjustment. The Jefferson method involves an iterative process. The divisor is adjusted downward rather than upward as with some other methods like the Webster method, until the desired number of sets is reached. When divisor is reduced, it increased the number of sets allocated to smaller regions. Step 3. Round down. After the divisor is adjusted, each region is allocated a number of sets, but any fractional set is rounded down to the nearest whole number. This process ensures that the total number of sets is not exceeded. Step 4. Final allocation. The goal is to have the most accurate and fair distribution of sets, ensuring that the smallest states or regions are not disproportionately underrepresented while avoiding the problem of overrepresentation for larger regions.
So, what is a Jefferson's method? A Jefferson's method allocates seats by finding a divisor that, when used to divide each state's population, and the result in quotas that, when rounded down, the sum to the total number of seats, and the divisor is adjusted downward as it needed to achieve this sum. So each method uses a divisor to distribute seats, differing on how quotas are rounded. So if you use Jefferson's method, you always round it down, and if you use Adams' method, you always round it up. And if you use Webster's method, you round it up normally, you round it up or down. So how does Jefferson's method works? So the population are divided by a modified divisor, rounding all the results down. And if the seat total is too high, the divisor increases. And if it's too low, it decreases. To prevent underallocation, the initial divisor must be smaller than the standard one.
Now, let us learn some terms related to Jefferson's method. First off is apportionment, the process of distributing seats among different groups. This is based on numerical data such as population or vote counts. Quota, a numerical value that represents how many votes or people are required to earn a seat. Different methods define quotas differently. Divisor, a number by which votes are divided in the divisor method to determine seat allocation. In the Jefferson method, the divisors are consecutive integers. Quota rule, a fairness criterion stating that a party should receive a number of seats close to its proportion of the total votes. Highest averages method, a type of proportional representation method like the Jefferson method where seats are distributed based on the highest averages after division. Seat allocation, the final distribution of seats to parties based on the method used. And lastly, proportional representation, a system in which the number of seats a party receives is proportional to the number of votes it gets.
Now, I want you to imagine that you're dividing 10 classroom prizes among 3 different student groups based on their members. A perfect division might require fractions of prizes, but you can't split the prize. So here comes the Jefferson's method, which adjusts the math to avoid fractions while keeping the total whole prizes equal to the target. The goal of Jefferson's method is to allocate seats proportionally based on population, while ensuring that the total number of seats adds up to the target number. To do this, we start by calculating a standard divisor, which is the total population divided by the total number of seats. This divisor helps us determine how many seats each group should get based on its population. However, since we can't have fractions of seats, we round down each group's quota to the nearest whole number. If the sum of these rounded down quotas doesn't equal to the total number of seats, we adjust the divisor and repeat the process until the quotas add up correctly. So, in simple and elaborate terms, we first calculate the divisor by dividing the total population over the total number of seats. Then we find each group standard quota by dividing group population divided by total standard divisor. And then if we see that there are fractions, we just round them down. For example, there's 4.56. We round down to 4 to the nearest whole number, which is 4. If there's 3.51, we round it down to 3. After that, we adjust the divisor accordingly. If the lower quotas give too few seats, we use a smaller divisor, and if the lower quotas give too many seats, we use a larger divisor. And then we repeat until seats match. So this is, in simple terms, a trial and error method.
Next is sample problem. This is our first sample problem. A country has 20 seats to distribute among 4 states based on population. The total population is 2 million. First state A, 900,000. State B, 600,000. State C, 400,000. And lastly, State D, 100,000. Use Jefferson method to allocate the seats. Sample problem number 2. A country has 15 seats to distribute among 3 states, with a total population of 1,500,000. State X, 750,000. State Y, 500,000. And State Z, 250,000. Find the seat allocation using Jefferson method. Sample problem number 3. A nation has 30 seats to allocate among 4 provinces with a total population of 6 million. Province B, 2,500,000. Province Q, 1,500,000. We have Province R, 1,200,000. Province S, 800,000. Use Jefferson method to distribute the seats.
So, based on sample problem number 1, the total population is 2 million and the total seats are 20. So, the first thing that we will do in order to solve this problem is to find the standard divisor. So, the formula in finding the standard divisor is total population divided by the total number of seats. So, substitute the given. So, 2 million divided by 20. So, if we calculate that, we will then have 100,000. So 100,000 is your standard divisor. So after finding your standard divisor, you will then compute the standard quotas. So the formula in finding the standard quotas is group population divided by the standard divisor. So based on our sample problem, there are 4 states: State A, State B, and State C, and State D. So State A has a population of 900,000 divided by the standard divisor, which is 100,000, then that will be 9. State B has a population of 600,000 divided by 100,000 equals 6. State C has a population of 400,000 divided by 100,000, that will be 4. And then state D, lastly, has 100,000 divided by 100,000, then the answer would be 1. So after getting all of the standard quotas, we will then round down if necessary. But since our answers are all whole numbers, we will just add all of these. So 9 plus 6, 15, plus 4, 19, and plus 1, 20. So you will then check if the total number of seats in the given problem matches your total number of seats based on your calculation. So since your answer is 20, and the given the total number of seats is 20, so our answer is correct.
Let's move on to example number 2. So adjusting the divisor. So this time we have 15 seats for 3 states with a total population of 1,500,000. So first we calculate the divisor, which is 1,500,000 divided by 15 equals to 100,000. So now we compute the quotas. So state X is 750,000 divided by 100,000 is equals to 7.5 or 7. The state Y is 500,000 divided by 100,000 is equals to 5. The state Z is 250,000 divided by 100,000 is equals to 2.5 or equals to 2. So adding this up, we'll only get 14 seats instead of 15. So we adjust the divisor to 95,000 and recalculate. So X, we have 750,000 divided by 95,000. So it's going to be equal to 7.89 or 8. Then Y is 500,000 divided by 95,000 equals 5.26 or 5. Then Z, we got 250,000 divided by 95,000, which is equals to 2.63 or 2. Now we have 15 seats in total, so the final allocation is X equals 8, Y equals 5, and Z equals 2. So we're gonna move on to example number 3, which is the larger population. So now let's distribute 30 seats among 4 provinces with a population of 6 million. So first we find the divisor. So first is 6 million divided by 30 is equals to 200,000. So calculating quotas, so province P have 2,500,000 divided by 200,000, so it's gonna be equal to 12.5 or 12. Then province Q is 1,500,000 divided by 200,000, it's gonna be equal to 7.5 or 7. Then province R, we got 1,200,000 divided by 200,000, that's gonna be equal to 6.0 or 6. Then province S, we get 800,000 divided by 200,000, so that's gonna be equal to 4. So adding them up, we only get 29 seats. So we lower the divisor to 190,000 and recalculate. So in province B, we got 2,500,000 divided by 190,000, so that's gonna be equal to 13.16 or 13. Then Q, we got 1,500,000 divided by 190,000. It's gonna be equal to 7.89 or 7. And R, we got 1,200,000 divided by 190,000. It's gonna be equal to 6.32 or 6. Then in S, we got 800,000 divided by 190,000. It's gonna be equal to 4.21 or 4. So we get 30 seats exactly. So the population is P equals 13, Q equals 7, and R equals 6, and S equals 4. So that is all. Thank you.
So to conclude our topic, Thomas Jefferson was the third U.S. president and the author of the first apportionment plan used in the United States. So Thomas Jefferson's method of apportionment played a significant role in the early efforts to ensure fair representation within the United States Congress. So, by adjusting the divisor downward, Jefferson's method favored larger states while ensuring that smaller states still receive a fair allocation of seats. So, the Jefferson's method of apportionment involves several steps to allocate seats fairly based on population. So, first we have initial distribution. So, this is where the total number of seats is determined and each state or region is allocated seats based on population using a standard divisor. So, the next step, step 2, is called iterative adjustment. So, this is where the divisor is adjusted downward instead of upward like the other methods, because this is to ensure the correct number of seats is reached. So, this increases the number of seats for smaller regions. The third step is called round down. So, after adjusting the divisor, fractional seats are rounded down to the nearest whole number to avoid exceeding the total number of seats. And then the last and final step is called final allocation. So this method aims to ensure fair representation by preventing overrepresentation of larger regions and underrepresentation of smaller ones. Now, while this method was used for several decades, it was eventually replaced by other apportionment methods as the political landscape and population dynamics evolved. However, Jefferson's method remains an important part of U.S. history and an example of the ongoing challenge of balancing representation in a growing nation.